actually share the P&R. If you know what a P&R, you see it in your booking or on your checking on your boarding pass. And typically, those two records are physically separated. So now you can imagine the synchronization issues here, especially in the last 48 hours of that booking. Because the last 48 hours is really taken over by the checking system, the departure control system. That's why it's called departure control system. So the idea here is that instead of depending on messages and all synchronization mechanisms and stuff, that we would have a single record. So that in itself is a challenge already, but that was the vision. The other vision, of course, was get rid of the mainframe and jump onto the next-gen system based on the entire Oracle stack, gigaspaces for in-memory processing, and of course IBM. IBM here will be happy to hear that. IBM, Red Hat, VMware, etc. technologies for the hardware and the system in general. When again we took over, then we changed slightly the direction of development, and we adopted Agile. And this is what this presentation is about. The Agile factory model. You will see some DevOps in it, no worries. So what is it? First of all, let's talk about Agile for a minute. It's not a process. It's a mindset. It's a set of principles, a set of practices, and a set of tools, but primarily the mindset. Mindset that we're talking about cross-functional collaboration. Not collaboration where you have the subject matter experts or product owners on one side, sending an email or document to a set of architects and developers who then send something to the testers. We're talking about real collaboration. Now, you can imagine that with a company like SITA being highly distributed, co-location does not exist. It's not real. So we had to come up with unusual ways of doing things. But I had to first get the buy-in from everybody. Because they were, what they saw was a failing product or failing program. We were ready to write it up. How do you get the people back to be motivated to actually do something, and especially when they are told, no, it's not 4 years that you have now, it's only 2. Well, you engage them and you make sure that they define their principles. So these are the principles that we define together. And one of the key ones is a clear and common definition of done. What do you mean by you are done? When you define your requirements, your design artifacts, when you do your code and you put it in SVN. What does that mean? What does that mean that the product is done when it's operational? It was obviously an iterative process. We wanted frequent feedback. We wanted frequent feedback from the SMEs through demos, but also from the DevOps team through frequent builds, integration, and testing. Very, very important that we built, integrated, and tested often to get that feedback. It was not just the feedback from a functional standpoint, it was also the feedback from an operational standpoint. For the rest, everything is, if you can see, identical with a common governance, with a common environment throughout the portfolio. And one more interesting thing is that we all agreed that to ensure that we had consistent integration, that we would have a heartbeat. Now, the pure agilist, I would call them this way, will tell you that the heartbeat or the time box needs to be exactly 2 weeks, or exactly 3 weeks, or exactly 4 weeks. That's going to start on a Monday and finish on a Friday. And from previous experience, that's what I started to do, and then I realized that that doesn't make too much sense as far as I'm concerned. Maybe instead of 2 weeks, we could have half a month. The value of this is half a month starts on the 1st of the month, finishes always on the 15th of the month, no matter what. And starts on the 16th and finishes on the last day. I don't need a Microsoft project plan to know that my iteration or my sprint is starting, or where I am in my sprint. Am I at the beginning, the middle, or the end? do I expect a delivery from offshore, 15th, that magic day? We had 42 iterations, and only 2 were not deployed, were not released on that day, only because Jenkins were down. So we had a little problem with Jenkins twice out of the 42 times that we had deliveries from offshore. And each product, okay, we're talking about 6 different products here, making up a system, were released every half month, the 15th and the last day. You don't have to worry about when it starts, when it stops, because you know automatically everybody has a calendar, and I don't need a project plan. I don't need a project plan because each iteration was defined not as start date and end date, because that was given, but as the scope, the backlog, basically, for each and every iteration. Each and every iteration was made of multiple sprints, and the number of sprints depended on the number of teams. We started in July 2011 with not a single line of code, no lines of code, except for weight and balance, because that had started earlier. But we had some serious issues in 3 years for departure control system, for sales and service, for inventory. Inventory we had started, and we had to get it up. We had to write it up. Basically, all the code that was written was not exactly good, so we had to get rid of it. That's the technical debt. That's part of the technical debt. We had also some issues with the foundation system, so we had to fix it as well. So lots and lots of work. Let's talk about the teams and their role. As I said, we are a distributed organization, and having 3 offshore partners, in 3 different countries, obviously, and 5 different locations didn't help. So we had to put in place cross-functional collaboration at different layers. In fact, 3 different layers. At SITA, we had what we call the cross-functional team for each and every product. And this cross-functional team were made of delivery managers, project managers, quality managers, but more importantly, subject matter experts, business analysts, and architects. So these people were working on an iteration basis. So you can imagine now, you have a half month to define your requirements along with your design, and your definition of done is to provide those artifacts on the 15th of the month to the next team. The next team being the offshore core team. The offshore core team can be seen as a proxy cross-functional team. The cross-functional team at SITA never ever managed a single Scrum team. The offshore core team managed the Scrum teams. So essentially, to the Scrum teams, the offshore core team is a proxy. And these people, who during one iteration, were responsible for clearly understanding. There was an overlap, by the way, so I'm making things a little bit square, but there was an overlap between those 2 iterations. And they were supposed to, and they did, in fact, understand the artifacts from the cross-functional team and plan, prioritize and plan, based on the dependencies. Now you have to manage dependencies as well. You have dependencies within the product, and you have dependencies between the products. So there are dependencies between the departure control system, the customer journey repository, that's the common repository, and reservation system and the inventory system, and even to the extreme, the weight and balance system. And many other external dependencies, because we depend on messages that we get from many, many airlines. So that team had a chief scrum master, a proxy product owner, but you can see also an integration and operational. Some people call it NFR. And we do have that term, by the way, at SITA, NFR, so, which I hate, by the way, Integration and operational testing management. So that, we're talking about DevOps here. We're talking about offshore having a team of dev and ops, of architects that take care of the functional piece as well as the operational piece. Now, this team was, the main responsibility of this team was obviously to get the artifacts, put them together, prioritize them, and feed then now the Scrum teams. Up to 52 working in parallel. At some point, some iterations had 52 sprints running in parallel in 5 different locations. And it works. It works if you organize your team this way, where you have little islands of responsibility, of ownership. If you think about it, at all levels, you own something. It's not just about being pushed something, you actually own it. Even though the core team did review and plan and prioritize and distribute the work, the Scrum teams were responsible for reviewing, understanding the requirements and design artifacts, and prioritizing within the iteration as well. The core team, what the core team did was simply prioritizing among the Scrum teams. The Scrum teams were responsible for committing to the development. Committing that by the 15th of the month and the last day of the month, I would get, or this team would get, the delivery. As I said, we had continuous build and integration, so on a daily basis we have that. But there is the final release, if you will, the 15th of the month, to be deployed on a very different system for the final acceptance from SITA. And that acceptance takes an iteration as well. Now you can see that definition and design takes half a month, review and planning takes half a month, development takes half a month, acceptance takes half a month. That's a 2-month cycle. So the first release out of acceptance is after 2 months, but then subsequently you have a release every half month. Because everything runs in parallel. Everything runs in parallel. Very important team. This team, in essence, and I will surprise you here, this ops team, or DevOps, it's actually a DevOps team, not an ops team, is not the data center. This is, again, another proxy. You have to imagine the development team, SITA and offshore, this DevOps team in the middle, and the data center on the right side. And that DevOps team was actually responsible for making sure that they would keep us on our toes, us, the developers, and also making sure that the standards of the data center were respected. The effect of this is the developers are not distracted with things that they don't care about and they don't even understand. And the data center doesn't get frustrated with things that they don't understand, like flexibility. And for a project or program of that size, with the velocity that was required, we don't want distractions. As I said, we had a couple of distractions with Jenkins going down a couple of times over a period of 21 months, and that was enough. So this team, of course, we had a manager looking across all products. It was not just one product, it was all the products, the entire system, with system architects, engineers, build and deployment engineers as well. So that's what makes up the team. The process, the delivery process, very, very simple. That will present what DevOps is, involving the 3 offshore factories. We actually call them factories because they were fed with raw material being requirements and design artifacts, and their production was software. What they were producing, by the way, they were producing, building, integrating, etc., and on their own environment, building and testing the final product from their perspective. But what we got every 15th of the month was the source code, the build scripts, the test scripts, all the documentation on them. We did not get a single executable. We had to, the DevOps team, rebuild everything from scratch. We built everything from scratch, redeploy everything from scratch, re-verified everything from scratch, and run from smoke test before the final acceptance. So typical, I would say, some people will say, well, this looks like waterfall, except that it's a highly iterative waterfall with a high level of collaboration among all the roles, and that's what makes it what it is. The agile piece was the pure, for the purist, the agile piece was at the offshore factory level. Now, if you think about it, you can apply the agile principles to everything. That's what we did. So every half month, the 3 offshore factories provided their source code that was accepted by the DevOps team upon certain criteria based on the definition of done. If those criteria were not met, they could not deliver. It did deliver. No severity 1 and 2 defects, or no known severity 1 and 2 defects. Of course, we discovered during the acceptance test some severity 2 defects, but no known severity 1 and 2 defects were of the essence there. A number of severity 3 and 5 defects, and also the delivery of what was committed. So it's not just about the quality, it's not just about the velocity or respecting a date, it's also respecting the scope that we agreed on a half-month basis. In fact, the plan was at the program level, cut and sliced and diced into stages of 6 iterations. So if you do the math, each stage is 3 months. So we had 6 iteration, if you will, releases, and one big stage release. So where was DevOps within the Agile Factory framework? I thought I would show you our organization chart. Doesn't look like it. The traditional organization chart, I call them more blame charts. So you start at the bottom and you go up and then you go on the other side. Who's to be blamed? And it's completely anti-DevOps, anti-Agile, anti-cross collaboration if you think about it. And quite frankly, the guy on the top, me, essentially, I don't know everything. The people actually do it, knows things, not me. I'm not here for that. I'm not here to micromanage people. And I'm here to provide the leadership, not the micromanagement. But this is our workshop. Look at it. Where is DevOps? Where is that DevOps team that I was talking about earlier? It's right in the middle. Purposely represented in the middle. That's where everything happens. Each triangle represents ownership, represents a set of activities that 3 different groups own. So for instance, integration management is not just the data center's realm. It's also the responsibility of architects and our platform team, our DevOps team. If you look at testing, typically testing is always QC. So QC will test. No, the responsibility of testing is among 3 groups. It's the software development, design and development group, as well as what we call the DevOps team, or the proxy ops, and the QC. That's how we were organized. If you look a bit more closely, and more specifically on the DevOps side, so I removed the 2 sides. The left-hand side is, I'll show you again. The left-hand side is a definition and high-level design, where the product owners are involved, as well as the architects and software development. And the right-hand side is the initial customer support. So you have here an end-to-end view of what software development is about. And software development is not just about producing code. It's not about producing functional code. It's about producing operational code. So if we look more closely at the DevOps piece and the shared responsibilities, the architects as well as the software developers, offshore principally, do interact with the software platform team or the DevOps team. That's when we work together. We define those scripts. We define whatever is needed from an operational standpoint. We define those specifications. With the data center, that's when we define what integration management is. Now you will notice that for once, the developers do not interact directly with the data center. In fact, in the 2 years or 21 months that we had this program, the developers, and I believe all 3 offshore partners did not interact with the data center, unlike what happened in the first 3 years. They interacted with people who could actually understand their language and could understand what the data center requires. That's a proxy, essentially. So we work a lot with proxies. And one of the reasons is obviously the fact that we're not co-located, which doesn't help. Different time zones, and you can imagine from India all the way to America. In fact, we had an office in Vancouver at some point, so we had to terminate that. But what's important to see here is that you have shared responsibility and proxies, essentially. And the last one, of course, is the release management part, where the business is involved, the transition team is involved. I'm not going to go into details, but that shows you the complexity of our development and integration and functional and performance test environment, with the mainframe being represented here because we get messages from mainframes all over the world. So we have to have that dependency. But in the final system, the mainframe is not in the picture, obviously. The primary role of that DevOps team was to define the environment and the standards in collaboration with the data center, to deploy the applications on our testing environments, track defects, detect problems, and discuss with the development team as well as the data center team the changes that are required in the system as well as the process. So it's not just the system, it's also the process that we discussed. We went through a continuous improvement program. Every 2 weeks we had retrospective, or every half month we had retrospective. Every 3 months or every stage, at the end of each stage, we had a mega retrospective across the board. And we didn't look only at doing retrospective for the sake of software development, but also from an end-to-end perspective. Life cycle is pretty typical. You start with a vision that you share with everybody, so that everybody's on the same stage. Define a strategy about your infrastructure and your standards. Plan your deployments. Deploy and review the software, and report on every delivery. Every week I get a report, essentially, that shows what's red and what's red and what's green. There's no amber, there's no in between. Either it worked or didn't work. Kept it simple. And the various tools that they manage, like Jenkins, Apache, Maven. Artifactory is a very important one, Subversion itself. So this is the context. This is what DevOps is about for us from a physical standpoint. Now, as I said in summary, that DevOps team, which sits exactly between the developers and the data center, made of system architects and system engineers in general, configuration managers, working extremely closely with the development teams as well as the data center, is really a proxy, and solved us many, many problems and avoided many distractions between the two teams. Their challenge was really to remain neutral, and that's a big challenge. You don't want to favor one or the other. And the results are that we managed to deploy the deployments that used to take 3 months now takes about 3 hours. Big, big improvement. So we're not talking about minutes. These are not just applications, they are full-fledged systems, extremely complex systems. I would like to finish on some thoughts and recommendations maybe. We believe that we have set a new way of working, and that's not just from a software development standpoint, but it's from the entire software development lifecycle. We have transformed the way we develop software, we engineer and develop software at SITA. I have shared those ideas and practices with many others at DevOps, at BCS, in America, in England, in Amsterdam, here now. And we have received 3 awards this year. The industry recognizes that we have done something quite unusual for an unusual program. One thing is clear, is that you can have the best process in the world, the best model in the world. If a few things are not done correctly, everything can fall down, essentially, like a card game. The first is to communicate, to set and communicate clear business and technical vision. It's not just business or functional vision, it's also the technical vision, operational, as someone will call it. Clearly define your roles, your team, essentially, and responsibilities, and the definition of done at all levels. A common governance and development environment, integration environment is a must. We have also to align, because we're dealing with 3 different offshore vendors here, and we have to, and many other suppliers, by the way. Those were the main 3. So we have to align the contracts with the model, with the Agile Factory model, and the business goals. Extremely important. It's not just the model itself, it's also the business goals. We did not do too well at first. We did very, very well with the model, but the business goals not so well for the first 6 months, and then we rectified the situation. And that's one of the value of being agile and doing retrospective so often, is that we look at it not just from a software development standpoint, but also from a process standpoint and a contractual standpoint. For a program of that size and complexity, dependencies are absolutely